Hello everyone, welcome back from the holidays. Uh, we're almost Sunday's over here, almost over, and we've got some clear skies over the weekend. Yesterday it was quite good seeing, and today we also have some clear skies. We do have the moon, which is close to full moon, and this kind of impedes a bit astronomical observations. Amateur astronomers dislike having a full moon most of the time because they focus on deep sky objects, astrophotography involving long exposures, and the brightness of the full moon that you can see here um, prohibits that. But moon is nice to image by itself, and this is one of the first objects that we have here, and that you can see. So we have a nice picture of the moon. We have the so-called terminator line here. It's the um, place where the basically the light from the sun ends, and we have the hidden side of the moon, and we see some nice we have some nice craters and valleys. um, Let me try to reduce a bit the exposure, and let's see if we can get a better view of the surface. So we are trying now a really short exposure for the surface of the moon. And as you can see right here, we have this beautiful image. We are connected remotely to the observatory, and it's running a Pi 4, an astronomy server, and because of that there is a slight delay, and the software is slower than a normal PC. So when you click something, you have to wait a bit for the action to take effect. So if it's not working, usually we don't panic, or we don't start pushing buttons all over the place, because it will crash the Pi 4 board and we'll need to reboot it. So we just click one, wait for a few, maybe 2-3 seconds, and usually something happens. All right, so let's zoom in this image. This is a still image of the moon tonight, as seen from our observatory here. So there are some nice features here that we can immediately see. I'm not very familiar with the landscape on the moon. I do know that most of the features that we have on Earth have also counterparts on the moon's surface. So we've got um, mountains exactly like named like those on Earth. We have so-called seas, which are valleys, and they appear a bit darker in these images. And we've got some nice craters as well. And in some craters here, you can actually see um, the these lines, these radial lines that are probably from the lava or the impact crater, with an asteroid. Um, so this is a nice image. I zoomed in a bit more just to get some more details of this. So you have the terminator line here. This is from here on, we've got a bit of the moon which is not lit yet by the sun. It will be in a few days. Next week we'll have a full moon, and that's really bad for amateur astronomers trying to image deep sky objects. But nonetheless, these are really cool because you see here, we can actually see, like in this place here, we can actually see the light inside these craters. We can see how these craters are illuminated, this one as well. And sometimes if we are lucky and we captured the moon in the right time, we can actually see sometimes there are some peaks in the middle of the craters, and you can see those peaks lit, and it's really wonderful to image. So we've got here a really nice moon, and now we are going to move to different objects. So it's a bright moon, so this means that we won't get pictures as good as on a moonless night, but I will try to image some double stars. We're going to go to Ursa Majoris, the Big Dipper, and try to see some nice stars, some famous double stars there, visual doubles, and one of them is a true double. So they're actually two stars in orbit of each other, and we'll try to see that as well. Then we are going to go to the twins, the Gemini. Gemini also have a nice Castor Alpha. It's called Alpha, but it's not the brightest star. This is interesting. It's actually the second brightest, but somehow people named it Alpha Gemini as if it were the brightest. It's not the only example. We also have Thuban in Draco, which was the North Star thousands of years ago. It's also Alpha, the main star in the constellation, but it's not the brightest. So Castor is a multiple star system. There are actually 6 stars in that system, and we'll see 2 and maybe the third. It's a full moon, and the moon is close to that location, so we'll probably not see the third one, which is really dim, but we will see the second, the two, the main A and second B component. And we'll also go to see a globular cluster. So the globular cluster in Pegasus M15 is nice to see today, mostly because that region of the sky is at a distance from the moon, and we can see it better. And we'll then go and see a galaxy which is M33 again in Andromeda, which is close to the Pegasus constellation, and we'll round up the day with M42 in Orion. This is a must for winter observations. It's visible with the naked eye. It's a really nice nebula where stars are born, and we will see that as well today. So let's do that. So again, I'm connected remotely. You can see here the software ECOS, which I use for controlling remotely the observatory. So I'm now inside. It's nice, warm outside. It's freezing. It's around, you can check and let you know what the weather is inside the observatory. So we have 2.5 degrees Celsius inside the observatory right now, give or take half a degree, because that's the accuracy of the temperature sensor. All right, so here you see the night sky as it is today. So we are going to go and see Miser here in Ursa Majoris, the Big Dipper, and then we are going to Pegasus. So we are going to go here. No, not Pegasus. Pegasus a bit later. We are going to go to Gemini. So we are going to go to Castor, and then we are going to go to Pegasus. M15 is here somewhere. It's a nice globular cluster. Most of them are really nice in the summer. So the summer constellations show a lot of globular clusters. And after we see M15, we're going to go to the M33 galaxy here in Andromeda, and we'll end the day going to Orion, the Orion belt, and underneath the belt we have the sword, the Orion Hunter's sword, and this is marked by the trapezium and the M42 Great Orion Nebula. So this is what we will be seeing today. Okie dokie. So let's start by going to Alcor and Miser. So we have the mount here. There is a slight delay, again, because of the remote software. It's a small computer connected to the telescope. It's a Raspberry Pi 4 running an Astroberry, so it's not as powerful as even as a let's say a smartphone, if you wish. So we are getting near the star system. So the scope has centered on the star system, and then we can try and see if we can actually capture this, if we are anywhere close to where we would like to be. So I will capture, and yes, there it is. As you can see, we are close to the visual binaries. So these are visual binaries. So these two stars here are not truly binary. They just appear to be close to each other and orbiting around each other. But Miser, the biggest one, is actually a double star system. So it has another companion that orbits around itself. So we're going to try to image that now. So let's have, let's say, 10 seconds of exposure time. And let's do it, and let's see the Miser star system. So we are now in deep sky, hundreds of light years away from Earth. And this is it. So this is Miser, this is Alcor, the companion. You can actually see them with your naked eye, and you can see here a bit that Miser is actually elongated. It's like an oval. It has an oval shape. So this shape is due to the fact that there are two stars there. They're not not just one. You can see the other ones are nice and round. And this one is elongated. You can see here part of the image. It's dark. This is because the telescope is so low right now. It hits there is a margin, there is something obscuring the horizon, my horizon in that area. So this is why you have this dark area here. It's probably there are some buildings there, and the constellation is low, and it's probably due to that fact. So let's try a shorter exposure, 5 seconds, and see how it looks with this exposure. Okay, so this is the double star system, Miser and Alcor. Again, this is an ED80 telescope, so it's 80 millimeters in diameter, so it doesn't have a very big resolving power, if you wish. So in these live snapshots, you don't actually see very well. You cannot actually see the two stars separately. You can do that when you post-process the images, or if you use a bigger scope. All right, so let's go back to this, and the second target. So this is Pollux, this is Castor, this is the first one rising. Probably this is why they named it Alpha, because it's the first one rising, and it rises after before Pollux. So maybe this is why they called Castor the Alpha star and Pollux the Beta star. So we are now heading to Castor. I am planning to install a camera inside the observatory to actually see how the telescope moves when we are trying to target. We are aiming and we are slewing towards these targets remotely. Okie dokie, so there we are. We are at Castor. So again, a few tens of light years. So Castor is closer than Miser to Earth, to the Sol system. All right, so let's try first, let's see if we are anywhere close to the system. So I will capture and solve and see if we are anywhere close to the Castor system. I'm doing 4 seconds of exposure time, and you can see here this is Castor, so we are right on track to Castor. So let's see Castor. All right. So you can see Castor here. You can see the companion star close to it. There are three main stars in Castor, and each of them has red dwarfs around them. So there are actually six stars in the Castor system. So there are lots of it's an amazing place to explore from this point. So this is Castor and its companions. And you can see a lot of background stars. These stars are further away from the Castor system. All right, so we are at Castor and we are trying to go to M. We're going to see the globular cluster. So this is really interesting, but to see the globular cluster, so I already searched for it here. So let's see where it is. So this is M15, and let's zoom in a bit and see where it is. So this is it. And let's go to M15. So M15 is a globular cluster, and you'll notice in a second why it's called globular. It's a very old structure in the universe. It's among the oldest structures in the universe. Compact uh, areas of space filled with stars. And it should be arriving. Yeah. Okay, so we are centered on, and this is going to be much more amazing than, let's see if we are where we should be. So again, capture and solve for 4 seconds. The solver crashes, and the reason why it crashes is that we do not, it's not bright enough, the sky. And because of the moon, we don't get enough stars in the image for the astrometry solver to determine where it is in space. So it was able here to find some stars, but others it cannot. So one reason, one way to handle this is maybe increase the exposure time and try to see if it works with that. It doesn't. It's not helping. But it doesn't matter. We are close to it. This is the globular cluster. So this patch here that we'll see with the main camera soon. It also has a different name. So there are various names in various catalogs. This is the NGC New General Catalog. M15 is for the Charles Messier catalog, French astronomer, 18th century, 110 objects. So let's do it justice, and let's do a 30-second exposure to this guy here. And we are exposing. So we are going to see the globular cluster at this point. Just a little bit more, the countdown here. We are doing a 30-second exposure to see the globular cluster. And it should be ready. And there it is. Small, isn't it? This is it. So remember, these are unprocessed. I mean, these don't look like images you see on the internet, colored images and nice, sharp images. These are raw images taken by the telescope. All of those are processed. You know, people spend a lot of time processing those images, but first, when they first take them, this is how they look like. Mostly black and white. And this is a black and white image. And you only get those nice images after you actually process them. I mean, there are various software starting from GIMP and Photoshop, plugins for astronomy. But anyways, going back to the star cluster. So this is the star cluster. Each point here is a star, and this bright patch here, fuzzy patch, is packed with stars, hundreds, thousands, tens of thousands of stars. Each of this point this is one star. Here you have thousands of stars. This is the difference. And you see that it's called globular because it's like a globular, it's like a globe, it's like a densely packed area of stars. So let me just double check to see if we are tracking. I'm not sure, you're not guiding here. I should be guiding. They are a bit moved. So let's start guiding. And you'll see in a second we have a star, and this is this cluster here. And we have some solutions here for the guider. And now if we come back here, we should have a better and sharper image of the star cluster, because we are now actually tracking. So let's give it a shot again. Astronomers and especially astrophotographers spend a lot of time imaging just one object. So for instance, to get a nice image like on the internet that you can see if you search M15 globular cluster, you'll those are hours of images, not just 30 seconds like we are doing right now. So they spend a lot of time imaging. So again, we have here, it's low on the horizon, and there are some structures here. This black area here is because of the structure on the horizon, and these patches here are probably dust on the telescope lens or the camera lens. It can happen. So these are an indicator I need to clean and double check once I have the opportunity, and the lenses and the camera, because this you can eliminate this dust, of course. um, yeah, so this is it. It's still a bit moved, and you can see the telescope moved here. It's having some difficulties tracking, probably because of the less number of stars available at this point. Even solving the plates is a bit difficult because of the full moon. But you can see the fuzzy patch, which is the globular cluster itself. This is a small one. It's not the best or ideal globular cluster to image, but the winter sky is not that rich in big clusters, especially not from the latitude we are observing. There are some really nice ones in Hercules and in Centauri, in Centaurus. Um, there is also a very nice um, cluster over there as well. So as you can see, we are very low on the horizon, and this is why the cluster doesn't look that good either, because when you are that low on the horizon, the objects begin to dim. They're not that bright anymore. It's called extinction. Because of the atmosphere that you have to look through to reach those uh, objects. There is a lot more atmosphere that the telescope needs to go through to reach the light of that object. If you look straight up, it's only a few tens of kilometers, and that's it, of thick atmosphere. All right, so let's go to M33. This is a galaxy, and this is here somewhere. Yeah. Okay, so we have a lot of objects here in M33, and I'm just gonna go here and see where we end up. These are objects that I've never seen before with this setup. So for me, they're as new as they are for you. I usually see them visually out on the field with the telescope. These are tests that I'm doing to check the equipment and do some calibration. Um, All right, so we are at M33. So I will just double check again. This is the small telescope, the guide scope that's taking these images. All right. So if I look very carefully, and if you know what to look for, um, you notice a patch here, and you can see this solver actually works because it has more stars in this area. So right now it worked, and it's completely centered in the where we should be, with an error of 5 arc seconds. So when you have a full moon, it really depends. There are regions of the sky with less bright stars. If you go near the moon, you won't be able to solve properly. But this area around M33 is rich in stars. And if for trained eye, I see here a fuzzy patch in the middle, which is the M33 galaxy. So let's go here. Let's track first. Let's make sure we are tracking. So I'll start guide. So it found a star, and now it found the solution for guiding. So now we are guiding. So let's go back to imaging this. And 30 seconds should work good. Now you need to remember that these objects, now since we have a full moon, they don't look as bright and as nice as on a night without moon. So the same objects that you've seen today look differently and brighter and sharper when you have a new moon. So let's see. Wow, this is nice. This is really nice, and you can actually see the spiral structure of the galaxy here. So you can see here we have, this is the core of the galaxy, the M33, and we have one spiral here, we have another spiral here, we have another spiral here, and we have another spiral here. So in this image you can actually see quite well the spiral structure of the galaxy. So let's take another shot. The tracking was bad in this image because you've seen the star trails. You shouldn't see any star trails, so the image is not that sharp. There are a bit of problems with the tracking. Well, this captures. I will prepare for you a some images I've taken. Yep. So let's see if we have the same issues now. Yeah, so now the stars are sharp. So this is a good image for stacking. So for which is a technique which allows you to get better, sharper images, and one of those nice images that you get when you browse the internet for astronomy images. But raw, this is how they look like before processing. So again, you see here the nice dots. I'm not sure if these stars are part of these ones that are really dim uh, here, these faint stars. I'm not sure if they are part of the galaxy itself or not. They are in the direction of the galaxies. They could be in front of the galaxy, most likely. Maybe they're from our own galaxy. But you can see here the spiral. Again, really nice. I'm going to make this smaller because once you zoom in, you get a lot of noise, and usually you don't. The best way to see these images is from the distance, zoomed out. And one thing that you notice here is the vignetting effect. So this bright area which covers everything except the corners. The corners are more blackish. This is because of the lens and the sensor. So there is more brightness in the center than on the margins, on the edges. So this is usually something that you can correct as well, but not when you do captures like this. You need to post-process everything. So this is the galaxy. And since we're here and we are seeing some galaxies, I want to go and let's see if, yeah, Andromeda is nearby. It's just around, is just over the street. If you wish, this is the Andromeda constellation. Oops, too much. This is the Andromeda constellation, and we have M33 and M31, the big galaxy that will collide with ours in a couple of million years. There is some lag between the remote server and, yeah, M33. Let's go to M31. All right. There is a bit of a lag in the connection. I'm now remote desktop connecting. I can also connect using BNC, but that goes over the internet in a remote server and comes back. So I don't want to. I'm now in the local area network, so I can do a remote desktop connection directly on the server. All right. So we are now on M33 here. So now I can right click and instruct the telescope to go to M33. 31. And this should be a quick move because it's close by. The telescope is probably already there, but the delay, the update, the refresh of the screen is higher at this point. So let's see M31. All right. And let's capture it. I am planning to do the whole Messier marathon. So on March 9, so on the night between the 9th and the 10th of March, I am planning on broadcasting the entire Messier marathon. So I'm going to take all the Messier objects one by one for the entire night. So that's Saturday night all the way to Sunday morning. And I will take all of them one by one and see what can be seen and how they look, and talk a bit about each. And in the meantime, I will perfect uh, the delay is a bit annoying. I know it's annoying for me as well, but this is what happens when you are remote connecting. I mean, I could put a full desktop PC there, but that's not the point, and there's a lot of humidity there, and I don't want to have all that. There is condensation, and it's not a good place to have some equipment like that inside there. So this is M31, and this is really beautiful, as you can see. And it also has a satellite. I always forget the name of the satellite. You can see here a satellite here, and I'm not sure about this one, but I'm pretty sure it's a Galaxy as well. Why I'm saying that is because if you look at the stars are sharp, but these are fuzzy patches. This one as well. So these are galaxies, and this is the Andromeda Galaxy. It's twice as big as the Milky Way, and you can see here the nice ring, not rings, spirals, and you can see the dark nebula that are in the galaxy, and it's really big. It's a huge galaxy, and it's getting closer as we speak. Um, so now you've noticed a few differences. You've seen the same settings. You've seen this nice, amazing galaxy, which is the Andromeda Galaxy, which before Hubble was known as the Andromeda Nebula, because people didn't know that there are objects outside of Milky Way galaxy. And you've seen M33, which is the Pinwheel Galaxy, if I remember correctly. If not, apologies. And you've seen the differences between, this is way more visible. You can actually see all the details. With M33, you could see a bit of the spiral, but you need longer exposure times for it. So, and you also seen that small globular cluster, which looked a bit like this small galaxy here, right? But I will image this again on a moonless night. and you'll have the chance to see them, to compare and see the difference. So this is an amazing galaxy. It's really nice to image. And we are going to go now to our final object for the night, which is the Great Orion Nebula, so M42, which is also visible with the naked eye. This galaxy is also visible with the naked eye, of course, as a fuzzy patch, if you know where to look. I'm trying to figure out why it's unresponding at this point. A bit of a problem here with the remote connection. All right, here we are. So let's so Taurus, and we've got Rigel, which is the one of the um, feet of Orion, and we should have Betelgeuse here and the Orion belt here somewhere, and the nebula is here. All right, so had a crash. I think there was a network crash. Yeah, probably a network connectivity issue. All right. So all right. Okay. So a bit of a connection problem at this point. Seems to be resolved now, hopefully. Okay, good. So we are back on track. The miracles of the internet and the mysteries of the internet. So we are going to the final destination, which is for the night, which is M42. Should be here somewhere where I clicked. There is a bit of a problem with the audio at this point, but this is due to my network connection, my internet. This also impacts the remote desktop connection to the telescope itself. But this is to be expected. All right, so we are at the Orion Nebula. Okay, so let's take a 30-second exposure of this guy, our last target of the night. I'm not sure if you can hear me or not. I'm indicated here that there is a problem with the sound. Okay, so M42, the Orion Nebula, an amazing nebula full of stars, and you can see the dark nebulas, the emission nebulas here. This is the trapezium, and these stars are young stars that are being born and formed as we speak. Okay, so this is all for the night. Another test transmission to double check, and seems that there are a bit of some connection issues, connectivity with the internet as well. But hopefully most of it was clear and interesting, and you've got to see some nice objects, especially the variety and these ones here toward the end, which are really nice and big and interesting. And you can also compare these raw images with images from the internet, which are processed. And if the weather permits, 19th to the 10th of March, we will be having the Messiah Marathon here. All right. Okay, guys, thanks for watching, and if you liked it, subscribe and stay tuned for more transmissions as we get closer to making this fully functional. All right. Thank you, guys. Thanks again. Cheers and good night, and enjoy the rest of the day if you're in a different time zone, and see you next time.